The last session of today's Tech Deep Dive, and the topic is, of course, nothing less than exciting, Agentic AI. So Agentic AI has been the talk of the town for the past months, but with every new technology, it comes with a very sharp learning curve. So today's I'm delighted to have our very own Agentic AI expert, Sascha Wolter, Cognigy's principal AI advocate and advisor, who will share with you deeper insight into this topic and review his treasure troves of tips and best practices on how you can optimize agentic experiences. Sascha, welcome on stage.
Yes, thank you for the nice introduction, Lou. And I'm sorry that Benny had to stop because of me. But hopefully I can add some interesting things on top of that, because what we will discuss now is the AI agents in general. And even if it's announced as a technical deep dive, I hope there's something for everybody into the session. So just for curiosity, who considers himself a little bit more, or herself, like a conversation designer, a more creative person? Okay, so there are still things for you. That's a good thing about that. And I think these are the most important aspects. Who thinks he's more or less a developer, more technical? Okay, that's 1/3. And also I have some things for you. Unfortunately, not that nice things. And no, I'm kidding. And the rest is more or less business users. Yes, some business users here. And this is, by the way, this is one of the biggest learning from my side, to see that with AI agents, we have, at the first time, something which business users really can use to create conversational experiences. That has never been that easy before, and I myself had so many learnings doing that. I have to tell you one anecdote, because I don't want to miss that when I run out of time. Because in one project, there was a business user. He wanted to move from the classic, more deterministic approach to the agentic generative approach. And he tried out generative AI, the AI agent approach, during the weekend. And then this person, he said he's totally convinced. He loves what the AI agent is doing. And I, as being part of the vendor of Cognigy, I had to say, well, do you see there's some kind of hallucination going on? Your agent that you created over the weekend is not 100% perfect. And he said, yes, that's like my peers, like my colleagues. That's perfect. I exactly want this. And this is quite interesting to see. Anyhow, I hopefully can show you some things, how you can compensate, how you can mitigate those risks. But overall, what is an AI agent? And there are a lot of terms around, and marketing loves to use this phrase, agentic AI agents, agentic behavior. But working with Cognigy in our realm, an AI agent is something which can automate things, which can do things autonomously, and most importantly, which can deal with conversation. That's quite important, especially if you talk to people who are more technical. Yes, people who, for instance, if you work in a large enterprise, who claim AI for themselves, developers, data scientists, who say, we are doing AI, we are the part of the company which is responsible for things like RAG and so on. And the interesting thing is, then you have to clarify what you currently are really discussing. Are you discussing conversational experiences in the realm of AI agents? Are you discussing agentic workflows, which is also some kind of agentic AI? So there are a lot of flavors discussing agentic AI. That's quite important. You have to clarify that. And the interesting thing is, even with Cognigy, which is a conversational AI platform, you can create agentic workflows. And we in terms of we eat our own dog food, we use that. For instance, our internal support bot is leveraging prompt training. And we use, if you're used to Cognigy, we combine the AI agent pattern with things like our LLM prompts. We chain different prompts together to provide suggestions for typical questions in our support team. And this works really, really well. So you see, you can combine all those things. And honestly, we don't care if there's a part in your company saying that they will do the agentic workflows, but if they are aware that adding a UI on top of that is crucial, then you can work jointly on the perfect solution. That's quite important to know. Anyhow, we also think we have to somehow work together with you. We have to learn together, and that's why we create a lot of articles. Here are some building blocks in terms of agentic AI, how you can use agentic workflows, how you can combine that with AI agents, and we frequently publish articles on that. And I think it's worth mentioning Nu, for instance, the moderator today. She's one of our greatest article writers, of our tech authors. I think give her a hand. She's really writing awesome articles. She promised me if I run out of time and can't cover everything, she will write articles on that. No, I'm kidding. I guess I have to do that on my own. Anyhow, getting back to the AI agents. Yes, if you talk about AI agents, the special thing about AI agents is that this is kind of an augmented large language model. So creating AI agents means you need agentic behavior, and for agentic behavior, you have to augment, you have to enrich large language models. This means, technically wise, that your large language model needs proper understanding, proper reasoning. It has to deal with large context windows so that you can use grounding, that you can enrich your AI agent with knowledge. And in the end, you need tools to somehow interject what the AI agent is doing autonomously. This is one of the challenging parts, because even if your AI agent is close to perfect, you need some hooks to get into the conversations to control that. And this is something you usually leverage using tools. But saying that, discussing agentic workflows, prompt chains, and things like that, tool calls, it's quite important to understand what really happens in the back and how you can optimize the overall experience. So for instance, this is a simple example where you can ask your agent to unlock an account. Yes, that's the simple idea. And here it's built in a way that your AI agent detects this request, because the AI agent can unlock an account. That's its skill. And then in the next step, there's an LLM prompt. So that means the large language model is again called to, for instance, do some sentiment detection. So what's the mood of the user? Is he good, bad? So you can react to that. In the final answer, that is the resolve tool action. But this involves 3 large language model calls, and this is a lot of latency. So in the first step, the large language model of the AI agent has to decide what to do to, for instance, select the tool. In the next step, you do some sentiment detection, classification, entity extraction, whatever. And in the last step, you have again a resolve tool action, which simply sends the result back to the large language model of the AI agent. So the AI agent knows the result, can process that, and decide how to go on. That's the third large language model call. And this, in a chatbot, is okay-ish. In an agentic workflow, it's not really a matter. But if you build a voice experience where you need a very direct, natural conversation, this will totally break the experience. So what can you do about that? For instance, instead of having your very own second large language model call for the classification, you can move this to the parameters of your tool. So inside this tool call, you have in the first step, in the first LLM call, you get already the sentiment, the mood of the user. So you get rid of 1/3 of the latency. And in the next optimization step, you could also get rid of the last step where you resolve the results. That means you send the result back to the AI agent, which then continues, which then provides a proper answer. You can ask your tool to generate the answer in front of the branch. So everything happens in one large language model call. So the large language model generates the tool call, it generates the parameter for the sentiment, for the classification, and it also generates a default answer. And you can generate several answers, one for the best case, one for the worst case, however, and it's still generative, it's still dynamic, but you don't need an additional large language model call. Well, indeed, everything comes with a cost. Yes, if your prompt you are using, the overall instructions and descriptions get very complicated, then this can also become slower than separating those instructions into several large language model calls. So you always have to balance that. But anyways, this also comes with a huge bonus, because thanks to this approach, you can now combine the generative approach with the classic elements. So that means you can place a classic say node here inside your branch. And this classic say node can use rich content, multimodal elements. It can now have images. It can now have a quick reply button. And the content of those quick reply buttons, or say nodes, is generated through the tool call. So this is a very effective way to reduce the large language model calls and to add to your AI agent rich content. And this makes everything more controlled, makes everything faster, and very, very user-friendly. And this is something we do a lot. Just as a side note, to give a small hint, what you have to consider here, this add transcript step is quite important, because a rich content is something which a large language model can't see, depending on the model and on the multimodality you're using, but maybe it can't process that. And with add transcript step, you add the essential data to the transcript of the conversation, so the AI agent knows what's going on. Even if there's something visible for the user, the agent usually can't handle, you can add a description so the AI agent is aware of that. And this is the power of combining all those worlds, combining the more deterministic approach with the more generative approach. And you have seen this slide, I think, several times, but I think there's one point which is not covered so far. This is the mental model. Because the interesting thing is, with the deterministic approach, where you have usually your natural language understanding in front, there you have to think, if you're a conversation designer, you have to think about all the possible ways how a conversation might flow. You have to pre-think the conversation. So that means you have to somehow discover what can the user say, which is then turned, or what can the user want to achieve, and this is then turned into something we call an intent, and then you create somehow the ongoing conversation. So what should then happen? If you work with the AI agent, it's the other way around. You don't have to pre-think the conversation. You simply define an agent and you define the skills of the agent. So instead of figuring out what the user wants and then creating intents like, I want to book a flight, you simply think about who is the perfect agent for this job and what skills are needed. And one skill is, I can book a flight on behalf of the user. And this is the idea. This is the new mental model. And this leads me to something which I think it's also quite interesting misconception here, because most people think we are somehow automate things using generative AI, large language models and agents, but it's way better. We create autonomous experiences. So we don't build Teslas. Yes, we build Knight Rider kit cars, which can argue with you, which can make decisions. And this is the real power of AI agents. This makes the experience really, really great, and you have to get used to that. It's not that your agent breaks if the agent creates a response you did not expect. It's just another way of arguing. It's like talking to your friends on a party. You can't predict how the conversation might go on. And this is exactly the idea of AI agents. So what I all the time do is if I'm involved in a project, or even if I have some issues at home, I think, who could do that on behalf of me? Who would be the perfect person? And this is somehow digital twin thinking. And then in the next step, I kind of write a playbook a persona, a description of this person, that's classic prompt engineering, with descriptions of role and tone of voice. I define goals, instructions, I define context, skills, starting questions, and so on. And then I simply distribute all those details into our AI agent description and into our AI agent's jobs. That's simply what I do. That's the overall approach. And then I have a first running version. Indeed, I have to add all the skills, as mentioned before, to make it more agentic, to somehow interject, to add business logic, things like that. And while talking about the business logic, something you have already seen, there are two ways how you can use the so-called resolve tool action path. One is for query transaction-based things, and then you give back the result to your agent, and the agent resolves that and creates the proper next step. And the other way is you don't use the resolve tool action node, and then it's like a classic branch in Cognigy. So then you can create your process. You can design whatever should go on in this path. And I said, both paths, so both ways, they have their pros and cons. It depends very much on the use case. But best of all, the best thing about this digital twin thinking is that the things you are creating, the digital twins, they can be everything. They can be persons, products, processes. That's the power of that. And for instance, I've created myself as an agent, as you can see here, and I'm very much into coffee, and hence I created my coffee expert. And the funny thing about that is, this is Sasha as agent, and you can discuss coffee recipes and how to make good coffees. You can discuss all the things with Sasha. But I recently bought a new coffee machine, and I thought I'd create a persona for this coffee machine, and now I can discuss with my coffee machine how to make the perfect espresso. Yes, and that's not all, because sometimes you want to discuss the coffee making process, the brewing process. So I also have Brewster. This is the coffee making process, and now I can discuss how to make the perfect espresso with Brewster. There's no change in the job itself. I only changed the agent itself. And this is quite flexible, and honestly, that's also a lot of fun, yes? I do that often in my spare time because I really like that and try out things like that. But to achieve the best result, you need to understand how our Nexus engine works. So how do AI agents work? And that's technically, it's really simple, because everything you write in your agent, everything you write in the job descriptions is combined to one playbook. That's the idea. So you get one set of descriptions and instructions for your agent, and the agent, depending on the model you're choosing, follows those instructions hopefully as good as you expected. And this is the idea, but indeed, to even make it better, our Nexus engine handles a lot of edge cases in the back. It adds some special instructions, so there's a lot of improvement in the back to make it even easier for you. But this is the overall idea, and as said, some additions are, for instance, safety settings to make it secure, to mitigate risks like prompt injections, and also to mitigate risks like side effects, for instance, hallucinations. But hallucinations is another interesting topic. The funny thing about hallucinations is the question, what exactly is a hallucination? Yes, and usually if you're a data scientist, data engineer, however, you will say if the facts are not right, if you get wrong answers. But what is a wrong answer? If you talk to business users, that might be something completely different. And most side effects we face in our projects, they do not result in wrongly grounded data. It's usually something which is a little bit more related to the overall design of your AI agent. For instance, if you have, I use another example. If Alex would be very generous in his AI agent description, but on the other side, in the job, you tell Alex to be very strict with compensations and refunds. That's in itself somehow contradictory. So what should Alex do in this case? And this leads to sometimes unexpected results, and then people say this is an hallucination, but it isn't. It's just a contradictory set of instructions, and Alex, this, let's say, intern doing this job does not know what to do. Yes, it's mixed up, and this is something you have to be really aware of. Another, a little bit more complicated kind of hallucination is this example here, where we created a tool which is called Manage Flight Bookings. There is nothing else defined in this tool, but the AI agent asks for details. Could you please provide me with your booking details? But we didn't define that. So is that a hallucination? Is that okay? And this highly depends on the model you are using, on the patterns trained in the large language model. Because in the data set of our model, there's often written, if you are somehow curious about your flight booking, you need booking details. Hence, our autonomous agent thinks he or she has to ask exactly that. And then you need, for instance, proper instructions to compensate that. You need some guardrails on top, validations, things like that. Another aspect related to knowledge is the topic like RAG, grounding. So how get you your actual relevant data into this agent? And one very powerful way is that you have your memory handling built in. And what we call long-term memory is simply a way how you can access customer data and get this customer data, including memories and things like that, into the context window of your AI agent. And one more way to get all kinds of structured data into the knowledge of your AI agent is the so-called short-term memory. This is simply a placeholder for getting your data into the agent. And this is both very, very powerful, but indeed, if you want to, you can also use RAG. I honestly think RAG is totally overrated, but however, we have RAG built into Cognigy. We have our so-called knowledge AI, and using RAG, we automate all the things I've mentioned before for you. We make it easy. So you can decide for your agent what kind of RAG-based knowledge you like to use, how you want to ingest this data, how you want to take use of that inside your AI agent. You can consider that always in each turn. You can consider the data whenever required. So there are several ways how you can leverage that. But if this is not what you want, yes, you are not limited. This is how it works in the back. And you can build your own pipeline to process whatever kind of data. It could be RAG-based data, it could be a knowledge graph you integrate here. You can do whatever you want. This is, by the way, this is the RAG description, more or less, how our RAG works for AI agents. But as said, you can use whatever you want, and you can even bring your own RAG. Whatever you want, you can combine with your AI agent, and for instance, add to the messages, to the transcript, to tool calls, or as said, directly into the memory of your agent. And this is a very powerful way of leveraging data knowledge. You can copy and paste with most modern models up to more or less a Harry Potter book and paste that into your memory. And this works really, really well. And as tokens getting cheaper and cheaper, it does not matter that much anymore. So this is something I strongly recommend you. However, I mentioned tokens. Tokens is another very important thing. First of all, Benny already mentioned that we have several ways how to deal with errors. You can define error handling. You can define fallback LLMs. And the interesting thing about that is we face mostly token limits. Tokens are somehow the currency your bot is using, your agent is using. That's the smallest entity of all the text processed. And if that's not proper defined, then you might run into issues. And unfortunately, if you have a fallback LLM, which is placed in the same tenet of all your LLMs, you still have the same error, the same issue, because the rate limits, the token rate limits, usually are shared. So it's important that your fallback LLM exists in another tenant, exists in another region, however you like to deal with that. But as said, tokens, that somehow the entities are used by all the large language models. And this is, by the way, what large language models see. That's the reason why large language models are not good in math, why large language models often fail counting the yas in strawberry, because they don't see the single letters, they simply see tokens. Yes, that's one of the challenges. But back to the tokens itself, make sure that you define proper token rate limits. And if you have trouble with that, then you need ways to figure that out. For instance, you can use a simple HTTP call to get the token rate limits. So if your AI department is not willing to give you access, there are some tricks how you can get the details. And those tricks are definitely not just tricks, they are part of our product. You can also track the token consumptions. Yes, and this leads me to the end. This is a little bit more related to prompt engineering, because this is something which is quite important, leveraging the power of AI agents, how to write proper instructions, proper descriptions. And there are still a lot of, yes, recommendations, patterns, however you name it, things you can reuse to improve your overall agents. But I personally would love to give you, I think, a more valuable hint. What I do a lot creating AI agents, I use the same lingo, the same language, so the same model in maybe our LLM prompt nodes or directly in ChatGPT or in some of those playgrounds. And I use those tools to create my instructions, because I made the best experiences if I use the same lingo and ask the same model, the same lingo, for a better writing of those instructions. Yes, this is a little bit like if you struggle to, like me, to speak English, but you speak to a native English person and ask this person to repeat what you wanted to say, and then you get most likely a way better result, which is processed better by other English-speaking people. And this is exactly what I do here. And this helps a lot. I also do that to summarize a long set of instructions and descriptions. And this works usually very, very good. And here you see my Socratic opponent. This is, by the way, one of the patterns you can use. A Socratic opponent is somebody who usually argues and is against what you are saying. And I created here a Socratic finance opponent to discuss travel expenses. Yes, so how to expense swimming trunks. And this is something, this is just a small tip before I have to go to the end. This is something I often do if I have some trouble family-wise. Then I ask my Socratic opponent how I can argue to not run into any issues. Yes, and this is quite powerful. Unfortunately, I did something very similar also with my own voice. Yes, I synthesized my own voice with 11 Labs, for instance. That's just a 10-second do you need to record your own voice, and try that with my wife. So I asked this Socratic opponent to talk to my wife directly, but the result was not as expected. Anyways, I wanted to demonstrate that live, but I'm running out of time, and luckily I have a small video I prepared on Tuesday, something very similar, which is really awkward, unfortunately, because I took my own voice and I combined that with another pattern which is called flipped interaction. And flipped interaction turns around the overall conversation. So not you as user ask the AI agent, is the other way around. Your agent asks you questions, something which is often done in simulations, something we are working on to improve the testing of AI agents, something which is used for learning, for educate people. And I did that for an example related to Who Wants to Be a Millionaire. We'd see if that somehow works with voice. I recorded that because usually you get a link and then you can see the Who Wants to Be a Millionaire screen on your phone, but I wanted to make sure that you can see and hear it.
What is the main ingredient in a traditional affogato al cafe? A, vanilla ice cream. B, whipped cream. C, coconut milk. D, chocolate syrup.
I think ice cream.
Correct. The main ingredient is indeed vanilla ice cream. Looks like you're off to a sweet start. Ready for the next question?
Yes.
What is the key flavoring ingredient in the classic tiramisu? A, vanilla. B, cinnamon. C, coffee. D, caramel.
Imagine you're the telephone joker. Can you give me a hint?
All right, here's your hint. This ingredient is what gives tiramisu its signature cake and pairs perfectly with mascarpone. Think of your morning pick-me-up. What's your final answer?
So I go with C.
Bingo! Coffee is the key flavoring ingredient in tiramisu. Looks like you're brewing up some solid answers. Ready for the third question?
Yes.
Which Italian coffee drink is made with equal parts espresso, steamed milk, and milk foam? A. Cappuccino. B. Latte. C. Macchiato. D. Espresso.
I click C.
Spot on! Cappuccino is the perfect balance of espresso, steamed milk, and foam. You're crushing it. Let me tally up your score for this round. You nailed it. 3 out of 3. You're clearly a coffee connoisseur. Want to dive into another round, or are you ready for a coffee break?
I'm ready for a coffee break. Okay, that's, yes, that took me an hour just to build that. My wife, she said it's ridiculous that I play with my own, with myself, but anyhow, that's it. Thank you.